So you'll remember last lesson, which was yesterday, we were looking into the Pythagoras' theorem, and these were the success criteria that we were trying to figure out. So identify what is the hypotenuse, so that's the longest side of any triangle. Calculate the length of the hypotenuse using the theorem. So remember, the theorem has three versions. You've got C equals square root of A squared plus B squared. Then you've got A, if you're looking for the A side, square root of C squared, take away B squared. And then you've got the B side, if you're looking for that, it's going to be square root of C squared minus the A squared. So you've only got three versions of the Pythag, depending on which side we are looking for. Okay, so first things first, when you do a Pythag question, always label the triangle, or at least, make a note of the triangle sides. C is always the hypotenuse, which is the longest side. A and B can be either or. It doesn't really matter. And we worked with 3D Pythag as well. Generally, with the 3D Pythag questions, okay, you'll have to find the sides of at least two of the triangles, because one, basically, you'll need because it's missing, depending on the triangle you're working with. Like, say, for example, here, okay, we need to figure out a couple lengths. So we need to find this length, and we need to find this length. But in order to find either or, we have to find another triangle, which is down here. This triangle. Oops. Okay, we have to find the length of this triangle, or some lengths of it, which was this. Okay, so most of the triangles in 3D Pythag, you'll need to find two triangles. Just watch out for that. And that's how we apply it into real-world problems, like I mentioned before. So today we're going to look into now the meaty part of what measurement is all about. And the idea behind today, or the intention, is to be able to calculate area of your composite shapes. Does anyone know what composite means? Composite. Yeah, composite just means more than one, or two things put together, two random things stuck together. That's what composite means in this context. So in terms of our success criteria, what we're going to try and get to is understand how to get the area of your 2D shapes. All right. Identify dimensions of your composite shapes. So basically area of composites. Find missing dimensions as well of your composite shape, and then calculate the areas of them. All right. So 4 things that we're going to try and be able to reach by the end of today's lesson, which I am confident we can. All right. So let's get straight into it. Before we actually start, one of the main things that we need to remember when it comes to finding the area of a shape is understanding the measurements of that shape, or the units that we've used to measure the length and the width of that shape. Okay, so I want you to recall this. You've probably seen this a million times, where we try to convert different units of measurement to other units. So if you have a shape that's in kilometers and you want to turn it into meters, you have to multiply that amount by 1,000 right there. If you're in meters and you want to make it into centimeters, you multiply by 100. And then from centimeters to millimeters, it's multiplied by 10. And then if you go the other way, okay, so if you're going from millimeters to centimeters, you're dividing by 10. And you'll see, because the numbers get smaller, as you go up. Okay, so you're dividing by the corresponding amount down here. You'll probably need to look at this again a few times when you do a question, because the reason why we have this, you'll have a shape that goes like this. Let's say you have a rectangle. And how do we find the area of a rectangle? Anyone know? Length times width, right? So let's say, for example, the length of this is 10 meters, and the width here is like 10 centimeters. Okay, what's wrong with this? Why can't we work it out just yet? What do we need to do? Yeah, you got to change the measurements to the same type. Either I want to make them both meters or make them both centimeters. So if I want to change them both to centimeters, that means if I change this to centimeters, okay, I have to go look at my little scale here, go from meters to centimeters, multiply it by 100. Okay, so that means this unit now becomes 10 times 100, which now becomes 1,000 centimeters. And now I can work it out if I want to find the area of it. All right, so those are the sort of things you got to watch out for with these questions, and hence why. Sorry?
The word.
What was it? Okay. But mainly, that's the main sort of idea with these questions. Okay, you'll have to change them into the same unit before you can do anything to it. Right, so what I want us to do is I want you guys to convert these into the corresponding units there. Just keeping in mind, like say for example, you're at kilometers and you want to go to centimeters. That means you have to multiply by 1,000 and then multiply by 100. Okay, so just keep that in mind when you're jumping 2 units. If you want to go from millimeters to meters, so this way, that means you have to divide by 10 and then divide by 100 as well. So you've got to do both of them. All right, so keep that in mind with these questions here. So I'll give you guys maybe 2 minutes to do these. Okay, you might need your calculator for these questions. Okay, so let's convert those units to the corresponding ones. Yes. So there's the solutions for that. Again, this is all doable without a calculator. If you just know, okay, that with these questions, you're just trying to move that decimal point. Let's say, for example, 2.32 kilometers. Shh, thank you. And I want to move it to centimeters. So kilometers to centimeters. I'm going to go times 1,000 times 100. So whenever you times by 1,000, all I'm doing is I'm moving that zero with the number of that decimal with the number of zeros. So there's 3 zeros, 1, 2, 3. And then next you're timesing by 1,000. So 1, 2. There's your decimal point. And there should be a bunch of zeros there in between each of those loopy things. Okay. Shh. Thank you, guys. All right. Let's go to page 20. Slide 20. Let's go to slide 20. All right, so let's get into it. According to this, the area of a composite shape is made up of a combination of simple shapes. So think of composite. The best way to understand what it means is combination of simple shapes. Just a combination, just a bunch of shapes that are simple, just put together. Okay, the area of a composite can be calculated by calculating the sum, so the total area of all the simple figures. And what that means is break up your shape into the simple figures first, and then you add them. Okay, and the other one is you can calculate the area of a large shape, and then subtract the area of a smaller shape. So what that means is sometimes you might have a square with a cutout circle in the middle. Okay, and I just want to find the area of this. Okay, what that means is, okay, you find the area of the square, and then you minus the area of the circle. Okay, that's what this is saying. Okay, so you need to make sure when you do these questions that you understand how to calculate simple shapes. Okay, simple shapes are the core of our measurement. Everything can be broken down into the most simple shape. Okay, it's easy. So our task here, what I'm going to do is I'm going to give you this handout. Okay, where we need to find some examples. Let me get that open here. So you're going to get this handout, and what you're going to do is, okay, what you're going to do, listening, is you're going to have a shape, you're going to have the formula here, and you have to come up with your own example. So I would like you to draw your own example of that shape. Like say, for example, this is a square. Draw the dimensions of it. A square, as we know, has the same dimensions, so that can be like 3 by 3. And the example of it would be area equals length times length, which equals length squared just means length times length. So you can just go 3 times 3, which equals 9.
So how would you do how would you do it the shortcut way? Would it be 3?
So another example here, if I'm doing a rectangle, so we're going to draw the shape of a rectangle and draw the dimensions of a rectangle. Obviously, they're not going to be the same, so this can be like 4 and this can be 5. Area of a rectangle is length times width. So as your example, it's going to be 5 times 4, and the area of it is 20. Now you'll notice that I haven't put actual dimension measurement types here, but you can if you want, and I would suggest you do so. Let's say, for example, these are meters. That means your answer for this one is 9 meters squared. Okay, if these are centimeters, so your answer is going to be centimeters squared. Okay, and there's your triangle, there's your rhombus, your parallelogram, your trapezium, your kite, your circle, and your sectors. We'll go through each of these together, but I'll hand you guys out the sheet. So when it comes to these shapes, remember what we're trying to do here is calculate the area of your composite. Remember, composite just means broken up into a shape that's made up of simple shapes. So what I want us to do is with these two shapes, let's just quickly identify what are the shapes that we're working with. So for this shape here, can anybody tell me what two shapes do we have? What are the two shapes that we can break this into?
Semicircle and square.
Yeah, you're going to say the same. Good. So a semicircle and a square. Now, what I like to do with these shapes is I like to redraw them so I actually can see what I'm working with. So for that semicircle, it's going to look like this. Okay. And it has, can anybody tell me, I can see that this has a diameter of 5. Why is it 5? It's a square. Okay, this is 5. That means this has also to be 5. But I only need the radius for this, yeah? So what's half of the diameter of this length here? What's half of 5, basically? 2.5, yeah? So that means I'm using, okay, a 2.5 radius. Shh. Okay, and then the other shape that I'm working with here, okay, is the square, which is pretty straightforward. It's a 5 by 5 square. Make a note of the actual measurements that you have there. This is in centimeters. So if I wanted to find the area of this, if I've broken it up into two parts, the area of the semicircle, okay, this is a tricky one, but don't get too scared. It's just a semicircle. So if I find the area of a semicircle, I have to obviously half it, okay? Because if I'm looking at the area, if I'm finding the area of a circle, a semicircle is half of that. So that means this will be pi times radius squared. But because it's a semicircle, just remember that you have to divide it by 2. Okay?
Did you a half then times?
That is also correct as well if you do that. It's the same thing. Okay? So you can do a half times that. Okay? And if you think about it, that's kind of like a sector as well because it's half a circle. So if I do that, that would be, I'll do it underneath, 1 over 2 times pi times 2.5 squared. So the area of that times, thank you Dylan, I'm going to trust you, but let me just double check, 2.5 squared, 9.8, let's go 2 decimals. That's 9.82 centimeters squared. So that's the first thing. I've got this semicircle. The next part is now, so if you want to copy that, the square. Shh. So for the square, you've got length times length because they're both the same. That would be 5 times 5. Therefore, the length of this multiplied will be 25 centimeters squared. So as a combined total area, when you add them, it's going to be 9.82 plus the 25. Okay, and as a final answer, that would be 34.82 centimeters squared. Okay, so that's how we do these questions. So you're going to split them up into 2 parts and then find the area for each one and then just add them together as a final answer. Okay, so do the same for this question, guys. I want you to break it up into its 2 shapes and then find its area. I'll give you guys, alright, I'm going to go through it. So for this shape, you've broken it up into 2. You've got the rectangle, okay, and the dimensions are 7 and 4. And then you've got the triangle, which looks like this. I know that this length here has to be 7 because it's the same as this. So that also has to be 7. Now the height here is a bit trickier, but shouldn't be impossible. I know that the whole thing is 10, and this section here is 4. That means the remainder here should be 6. All right, so that's 4, that's 6, so this should be 6. All right, so for the area of this, so the area of a rectangle, remember, is length times width. So we know that here it's going to be 7 times 4. The area of that rectangle is 28. And then for the triangle here, I know that the area is base times height. And then you divide it by 2. So according to this, my base, that length there is 7. My height is 6. Divided by 2. And that should equal 21. Okay, so adding them up, so you've got final answer 28 plus 21. As a final answer, it's going to be, so you remember that's your rectangle, that's your triangle. Okay, adding them together, the total area is 49. What's the measurement here? Is it centimeters? Oh, it's meters. 49 meters squared. All right, that's that. Nice and easy. 49 meters squared. So again, the principle here is you're just going to break it up for the composite shapes into its most basic. Okay, and then after that, find the area of each one separately, and then add them all together. Okay, into this. Okay, and add them all together. What I think is a really helpful thing in the SAC is because sometimes you might get like 4 or 5 composite shapes and you need to break it up. I like to actually underline what are the numbers that I'm adding together. Yeah, so just make sure you make a note of that, because it does get really crazy when you have like 4 or 5 different things you have to calculate. So just underline what you need to add. Really helps. Yes.
The first one, the circle one.
Yep.
Why can't you just use the diameter instead of doing the radius?
Because for the formula of a circle, it's always with the radius. Yeah, always with the radius. You don't use the diameter, you only use for the circumference.
Okay.
Yeah, but when it's area, use the radius. Good question, Abby. All right, let's go to the next part. In here. So this one here, it's a worked example. Okay, but there's multiple ways you can do it. I think the letters really confuse me a little bit with this. But can anyone tell me what can you break this up into?
3.
You can break it up into 3 parts like this. Okay, or you could go into this way as well. Okay, that's the most popular ways, but there's always one way that most students never really think about. There's the third way. How can you actually calculate the area of this? Good. Do the whole rectangle, and then you minus the little bit. That's another way of doing it. So let's do it that way. So if I want to find the area of the rectangle, the whole thing, let's draw it to scale. So I have this whole rectangle, BHG. Okay, what's the length of it? Well, I know that this is going to be 10, because that's 10 there. And this whole length on the side, okay, what's that going to be? Well, I can see, okay, looking at my shape, according to this, that's 9. And this is also 9, yeah? So these 2 parts are 9. And you can see that this whole thing is formed by these 3 sections. So that, this length, and this length. So that's 9, that's 2, and that's also going to be 9. So adding them together, 9, 9, 18 plus 2 is 20. That means this whole length here is 20. Now that's easy enough. What's the area of this without using your calculator? 10 times 20? 200. So we can say that this whole thing, 200 centimeters squared. So that's the first part. The whole thing's 200. Now I need to figure out what's the tiny bit, the small teeny weeny bit here that I have to recognize to remove. So that's this bit here. I've got to remove that. Okay, so that length and width of it, look at the shape. I can see that this bit here is 5, so that's fine. Okay, and this bit here is 2. Obviously, it's not to scale. Okay, so just keep that in mind. Because, yeah, that doesn't look right. Not to scale. So 5 by 2, length times width, it's going to be 5 times 2, which equals, 10 centimeters squared. So, as a final thing, remember what Michelle said is I've got to find the area of the whole thing, and I'm going to minus that little red section there. So, so that means for the final area of it, it's going to be 200. Oh, what I'm basically doing here, by the way, is big rectangle, take away little rectangle. Make that more rectangular. Okay, that's all I'm doing here. So big rectangle minus little, 200 minus 10. Remember, these are the things that I'm working with. So that will equal 190 centimeters squared as a final. Okay, you can do it the other way, where you guys broke it up into 3 shapes. That's fine as well. But this is the premise for this one, is sometimes you'll need to minus some of the areas, depending on the shape. All right. Everybody copied it down? All right, we're going to move on. I have a challenge for you guys. Let's leave that. I want you guys to, in your table, so with your duo that you have in your table, so working as partners, I want you guys to pick one of these shapes and find the areas for them. One of them. These ones are a bit tricky because they're working with circles. Okay, so one of them. Pick one of them, find the area of it.